Hello and welcome to another episode of the Quantum Connection Roundtable. I am Lauren Bradley here with my co-host Kelley Erickson. And today Kelley and I are very excited to be joined by our guest, Morley Robbins. Morley Robbins, MBA-CHC, is the creator of the Root Cause Protocol and author of the book Cure Your Fatigue. That's with a CU in elemental parentheses. Also known as the Magnesium Man, Morley is one of the foremost experts on magnesium's role in the body and the delicate dance magnesium plays with iron and copper and calcium. He received his BA in biology from Denison University in Ohio and holds an MBA from George Washington University in healthcare administration, with additional concentrations in finance and marketing management. Morley has completed his training for becoming a Well Coach's wellness coach, a ULAN nutritional counselor, a functional diagnostic nutritionist, and completed 2 levels of Jerry Tennant, MD's Synergy Institute. In 2012, Morley founded Magnesium Advocacy Group and remains the de facto leader of the Magnesium Advocacy Group on Facebook with almost 200,000 members and growing weekly. As a certified health coach with an expertise in hair tissue mineral analysis, that's HTMA, Morley has performed over 6,500 one-to-one consultations with clients from 45 countries around the world. After reading scores of books and thousands of scientific studies and articles and counting daily, Morley has come to realize what the scientific peer-reviewed literature from around the world makes very clear. Even though it is not well known in conventional medical circles, all disease is caused by inflammation, better described as oxidative stress. And the root cause of this inflammation, oxidative stress, is cellular metabolic dysfunction, which is caused by an imbalance and dysregulation of 3 key minerals: copper, magnesium, and iron. The imbalance can be repaired, and we can feel much better following the steps of the root cause protocol. Spreading the news about these mineral truths is now Morley's full-time mission. He views it as his life's work to push back the tides of nutritional insanity, supplemental iron, and is fully committed to educating as many people as possible about how they can use the RCP to reverse this root cause, mineral imbalance, and end the plague of fatigue that fuels chronic disease throughout the world. Research highlights that there is a connection between experiencing fear and the activation of the sympathetic nervous system, or the fight-flight response, and iron overload. Excessive iron accumulation, particularly in the brain, is directly linked to anxiety and other stress-related disorders and dis-ease. The connection stems from the effects of stress hormones on iron metabolism pathways, which alter iron uptake and distribution within the brain. Iron overload or dysregulation alters our magnetic footprint and disrupts its interaction with light, leading to oxidative stress and chaotic biophoton emissions. These changes interfere with the subtle electromagnetic fields and light-based signaling that sustains the etheric energetic body, causing imbalances in energy flow, coherence, and grounding. Such disturbances manifest as both physical ailments and disruptions in the emotional and spiritual well-being, underscoring the intricate link between iron regulation and the health of also the energetic body. Excessive ROS generated by iron overload not only damages physical structures, but also creates energetic turbulence within the etheric body, which thrives on coherence and harmony. We talk about emotions and consciousness creating reality on this podcast. And a very big part of the root cause protocol is teaching people that stress connected to symptoms and mineral imbalance is a very important realization and resolution step in the healing process. We are so excited to have you here today, Morley. Kelley and I can't wait to dive into the subject of iron and fear.
Fantastic. This will be a lot of fun. It'll be a very engaging conversation, I'm sure.
Yes, as always, as
Yeah.
always. So if you want to start us off with laying the groundwork of the understanding of the iron equation, then we can unfold from there when we have foundation.
Okay. So let's start with the basics. The number one element on planet Earth, 36% of the Earth's composition is iron. The metal that has the highest concentration in our body is iron. So we're dealing with this is a very dominant force. And what is its recognized role? It's the master pro-oxidant metal on the planet. It's a very powerful part of our environment and our body. And the other thing we have to acknowledge is that we live on a planet with oxygen. So upwards of 21% of the air we breathe has oxygen, and we can't live without it, but we can't age without it either, because the whole mechanism of life on planet Earth is based on the fact that iron is a weighter in our body. It's carrying oxygen. 80% of the iron in our body, dumber than a box of rocks. It's carrying oxygen to the mitochondria. And those are the organelles. There's a lot of them, 40 quadrillion. So that's 40 billion million mitochondria. And that's where the oxygen payload is delivered. And that oxygen needs to be turned into water, 2 molecules of water, to release ADP, the precursor energy molecule, to become ATP. Now, what's important for people to understand is that iron is the waiter, but every great restaurant has a chef. And no one's ever been told that, in fact, the chef in the mitochondria is copper. And I could spend the rest of the day telling you about what copper does inside the body, but then we'd blow the whole purpose of the conversation, right? So, but the thing is, we're trying to get a foundational understanding that there's tremendous tension between copper and iron as it relates to oxygen. They don't have the same, the reason why life exists on planet Earth is because copper saved the day when oxygen began to appear on the planet 2.5 billion years ago. It's called the Great Oxygen Event. And it's a great mystery to the astrobiologists. Why all of a sudden did the phytoplankton in the primordial sea that was dominated by iron and sulfur, why did they start to engage in photosynthesis with the sun? And anyone who knows their biochemistry knows that the process of photosynthesis is going to give off oxygen. And so oxygen started to go into the sea. And then after some extended period of time, it started to drift out into the atmosphere. When there was 0.1% oxygen in the air, today it's 21%. When it was 0.1%, 99% of life on the planet disappeared because life was anaerobic then. There was no oxygen. And the reason why we're here, the reason why we're having this very switched on conversation with very sophisticated technology, is that higher order thinking required greater energy. And what copper brought to the planet, what copper brought to life on this planet, were 3 critical chemicals that we can't live without. One is there's a whole class of enzymes called multi-copper oxidases. Okay, so anytime you see the ending of the word is ASE, you know you've got an enzyme. And so this enzyme is metabolizing oxygen. And so these multi-copper oxidases love to turn oxygen into water. They do it all day long, oxygen into water. Turns out we have 1,000 different forms of multi-copper oxidases in our gut. Maybe it's important to convert that oxygen. And so you can't release energy if you can't turn O2 into 2H2O. I think it's the most important chemical reaction on the planet. Second chemical that's really important, everyone's heard of it, melatonin. We know it as a sleep aid. Well, actually, it's a master antioxidant inside the mitochondria. And what's another name for the mitochondria? Purple bacteria. Why are they purple? Because the complex, the kitchen where oxygen becomes water, is blue. It's sky blue. Go outside, look at the sky. That's the color of all of your complex fours in your 40 quadrillion mitochondria. And what does blue tissue absorb? Red light. That's why red light is so important for helping people get better, is that people have underperforming mitochondria, but they get stimulated by that red light. And then they start to complete the energy cycle, so they feel better. So melatonin is very, very important in the process of neutralizing the oxidative stress that's bound to build up in the mitochondria. And then the third chemical that is, I think, the most important, and again, we're talking about the beginning of time here on the planet, some billions of years ago. This pesky little chemical called cholesterol was made. What most people don't know is that it takes 11 molecules of oxygen to make 1 molecule of cholesterol. So what is cholesterol? It's an oxygen sink. And so Mother Nature recognized that there was a need to park that oxygen for later use. And so anyone who has, quote, elevated cholesterol, well, it's just a clinical sign of copper deficiency. And the guy who figured that out, his name was Leslie Clave. He's an MD, PhD, cardiologist. In 1973, he figured out that, oh, this cholesterol thing is a copper issue. What was happening in 1973? Statins were coming on the scene. And so for his theory to be adopted science, only one other lab had to confirm it. Well, since 1973, over 30 labs have confirmed that Dr. Clave was right. Cholesterol is just an oxygen sink. It's a sign of copper deficiency. And what's the number one product on planet Earth? Statins. We just have to spell it right. $TATIN, $. And so we live in this farcical grade B horror flick called Planet Earth, where everything is upside down and backwards. So I think it's important for the listeners to understand that we're going back to the beginning of time. We're going to talk about fear and think about what life was like as oxygen was coming onto the planet. If 99% of life disappeared and you survived that, do you think you'd be a little nervous around oxygen? Get a little fearful around oxygen? And so within the root cause protocol, we spell fear differently. It's Fe-AR. That way you see the symbol for iron. But what people need to understand, and we'll get into it as we have the conversation, people are pretty conversant about hormones, a certain subset of hormones. But what I've come to realize is that all hormones are responding to the state of oxygen in the body in which they reside. There's a reason why estrogen does what it does. There's a reason why progesterone does what it does, or testosterone, or adrenaline, or cortisol, or you name the hormone that you think is most important. And you can back into what's happening to oxygen and its conversion into water and ultimate conversion into energy or release of energy. And that's when the hormones become more animated or less animated, depending upon what's going on inside the physiology of the individual, but also the psyche of the individual. Because if they perceive a threat, they're going to become hypoxic. and then everything's going to start to go into a tailspin. So hopefully that gives people some basic foundation for what we're going to talk about, because it's really simple when you really get into it. And I think, Laura, you certainly appreciate that, having been through the program, but then just the work that you've done. And I can't wait to learn what Kelley's perspective is on this, because to me, it's so central to life on the planet, is we don't understand what the greatest stress is. The greatest stress is oxidative stress. It's this tension between copper and iron and oxygen, and I call it the three-ring circus. That's what causes the chaos on planet Earth at a physiological, a biological, hormonal level, is this tension between those two minerals and oxygen. And where you were talking in the introduction about magnesium, magnesium always takes it on the chin. Whenever there's oxidative stress, boom, magnesium is going to be kicked out of the tissue. It's just, it's how the kinase enzymes work and how they respond to heat stress and oxidative stress. And it's just, you can drink a bucket of magnesium, but you're never going to correct the copper iron conflict until you begin to understand where that tension is coming from. So hopefully that makes sense and gives us a platform to work with.
Yeah, the term oxygen, I think, makes me think of our breath, which makes me think of the out breath and the in breath and the constant pendulum swing.
Right.
And a lot of the pieces of the RCP are designed to adhere to the seesaws that elements are on, the seesaw of iron and copper, the seesaw of magnesium and calcium, the seesaw of vitamin A and vitamin D, those relationships, like an in-breath, like an out-breath, right? And the fear, I think, and I'm going to maybe get a little meta, the fear, right, comes from a lack of that bidirectional relationship, which is the lack of balance. It's the lack of receiving and sending and swinging back and forth, right? And
Yeah, absolutely. Yeah, but most people that we work with have been given a label or some diagnosis led to their state, whatever it is. I was just talking to a client who several months ago was told by her endocrinologist, as opposed to European endocrinologist, but she was told that she was hypothyroid.
yeah,
And the doctor was gearing up for, massive medication, and somehow she caught wind of the RCP. And in 2 months, and her husband's a physician, he's an anesthesiologist. And in 2 months, all her symptoms are gone. Her blood work, her thyroid focused blood work, is completely normal now in 2 months. And the doctor is incredulous, saying, "What did you do?" And she said, "I just turned to Mother Nature." And so people, what would be useful for people to know is that if you have been given that label, hypothyroidism is just a clinical sign of vitamin A deficiency. The thyroid really digs retinol, animal-based retinol. And retinol likes to hang out with copper. And what do they like to do? They like to regulate iron. And it's just, it's so elegant and so simple, but people keep looking for complicated solutions. But that's just one example. Anytime someone gets a label, there's a increase in their anxiety because they think they're broken. And the first thing I tell people when I'm working with them in a consult is, you're not broken, but you are out of balance. Back to your observation. And the analogy I use is for people is that, go back to when you were trying to balance yourself on a boogie board, like you use for skiing. Well, if you go down on one side or the other side, there's no energy required. because the board is stationary to the floor. But the minute you get the boogie board into the middle and you're trying to balance, what does that require? It requires energy. Balance in the body requires energy. And you've got to be able to turn oxygen into water to release the energy so you can stay in balance. And as soon as you aren't making optimal energy, and this is the genius of Jerry Tennant, as soon as you're coming off the optimal point of energy production, the pathogens wake up. They're like, hey, party time. We got someone who's low in energy. Let's go for the jugular. And then everything starts to unravel at that point. And so at a cellular level, at a primal level, there is fear when there's lack of energy. And that whole concept of not being able to respond to the environment is very threatening to the individual and to their psyche, because we're supposed to be able to respond to our environment. We're supposed to have the energy for resilience. That's what the whole basis of our physiology is the environment's changing. I've got to do something different. But if you can't mobilize the energy, then you go into a state of fear. And you're either going to go into fight, flight, or freeze. And that I think it's that basic. Does that make sense?
Yes.
Okay.
Yes.
Okay.
Yeah, I have a question for you. So you had mentioned that red light is important for the mitochondria and the production of energy. And then you also highlighted how hormones are made from cholesterol. So I was just curious if you had any thoughts or explanation on what happens when we expose our skin to UVB light and that cholesterol conversion process begins to take place. Is there a massive amount of oxygen liberation under UVB light?
Well, Kelley, that's a beautiful question. I don't know that I have an answer. I've never thought of it in that sense.
Okay.
That's really cool. Is oxygen being mobilized? Potentially, I guess potentially it is. It would make sense. Um, I think the point that we want to emphasize, though, is two aspects to that. That UVB light is interacting with a vitamin called folate, B9. And back to one of my heroes, Leslie Clavet. Um, amazing mind. He's now 90 years old and still going strong, still publishing. So I had this theory about B vitamins and copper and iron. I said, Dr. Clavet, I think all the B vitamins are copper dependent and they're there to regulate iron. And he said, well, Morley, he said, I can't speak for all of the vitamins. He said, that's a very interesting theory. He said, well, what I can tell you for a fact is that B9 is copper dependent. And that was a watershed conversation. Years later, I was talking to an alchemist who happened to be a 40-year veteran of chiropractic and 40-year veteran of naturopathic, but he spent 30 years studying the alchemy of copper and iron. And he said, the most important thing I think you need to know about copper is it has a magnetic attraction to sunlight. And so, and I know Lauren knows this, and she's like, she's a sun goddess. And
So is Kelley. But this is
okay,
this
but
is great because I have so many questions
I know,
too on magnetic and electric.
yeah,
So
right,
carry
right.
on.
But so the thing is that the B9 has folate, but it's what's allowing the synthesis of vitamin D to convert the cholesterol that you just mentioned. And now you've got my wheels turning, like, oh my gosh, there's oxygen. Oh. But the other side that no one thinks about is that retinol needs to be broken down in that same sunlight.
Yep.
Everyone knows about, oh, I got to have my vitamin D. I got to go outside, stark naked at the equator and get some vitamin D. You need to worry about your vitamin A. I think it's 1,000 times more important. And we live in this world of dementia, both literally and figuratively. And so we've got to start focusing on what they don't want us to talk about. And that's things like retinol and light and oxidative stress and so on and so forth, which we'll get to. But the key is getting people to realize, as Lauren, as you mentioned, there are these seesaws. And one of the most important seesaw is A and D.
Yeah.
Don't just do D, don't just do A, but I think, to me, physiologically, A is just profoundly more important than vitamin D. But we're just being pummeled to death with all this literature about D that I think is really wearing us down.
You've said to me, vitamin A is the light activator,
Sensor, light sensor. Yeah,
and vitamin D is the light dimmer,
yeah, or filter, right? Right.
filter,
Yeah.
right? Well, activator A, D
Okay,
dimmer.
okay, I'm with you. Okay.
Yes, yes.
My
So,
apologies, right? Yeah.
so we need the activator, and then the dimmer, which is in storage, right? Or the filter, which is in storage. Can you go
Well, yeah,
in?
the thing is, retinol was on the planet 700 million years before vitamin D. Gee, that's a long time. I don't know
Oh,
why. I don't know why. I don't really know why. I remember the statistic. I'm like, wow, that's a long time. And the, the so much of our understanding of um, these hormones, they're both hormones. Hormone D and hormone A. Retinol produces four hormones. The retinoic acids, all trans, 13 cis, 11 cis, 9 cis, those are really powerful hormones. And all people can think about is vitamin D.
yeah.
It's like, so literally the mechanics of the body does not work without those retinoic acids. So that's important for people to know. And then the nuclear receptors that are made from the retinol, the RARs, the RORs, the RXRs, the RZRs, all those are different nuclear receptors that marry up with other receptors to allow transcription to take place. So back to hypothyroidism. What is the real mechanism of action? Well, if retinol is not there to become RXR, to marry up with the thyroxine receptor inside the nucleus, you can't transcribe thyroxine hormone. It doesn't happen. And
Mhm.
so if there's an underproduction of the hormone, it's because RXR wasn't being made. And that's a dietary issue. It's not some monolithic mystical issue. It's like, if it's not in your diet, it's not going to be in your body, and it can't allow the nuclear machinery to work. And so I think the key is getting people to appreciate the importance of sunlight, the importance of these nutrients in our diet, the importance of silencing the automatic negative thoughts that we all live with, the importance of minimizing the environmental stress that we're in, the towers, the chemtrails, the water, the whatever, the food that we eat, and begin to recognize that there are some macro environmental forces that we can take control of, so we can optimize the energy, so we can optimize our response to our environment.
Yeah. So retinol, just so everybody in the audience, retinol is fat. You get your food-based whole complex retinol from fat from animal tissue. Morley uses the acronym FAT from animal tissue. So this kind of explains why veganism, you are not getting the proper fat light activator for the conversion of energy, right? Which also, and also the conversion of iron, the relationship between iron and copper. Um, I think it would be really awesome to talk about iron overload and what's happening with
Sure.
iron overload. And I want to talk about it in terms of like also touching into magnetism. And here's where the fear would come from, where you're unoriented or altered orientation to your reality, which is made up of light. And so that fear starts to manifest because the proper electric and magnetic properties of iron and copper are dysregulated because you have too much copper. I mean, sorry, too much iron in your system, in your tissues, oxidating. And to me, I think that if you have iron overload in the tissues, you have iron overload in the aura, in the energetics.
Yeah.
And so that changes the magnetics of your relationship to elements that make up particles of reality, and that is going to orient somebody to a fight flight set point.
No, you're absolutely right. And we're only going to have an hour and a half to talk about this.
I know, right?
So let me share a little factoid about retinol
Yeah.
to get back to your points that you're raising about iron overload. Again, I'm not trying to turn people into microbiologists, but I think people need to understand some of the basics of how the communication or electron movement takes place inside the mitochondria. There's 5 complexes. You have complex 1 through 4, which is called the electron transport chain, for a reason. Electrons are moving down the chain. And then when that's coupled with complex 5, that whole concept is called oxidative phosphorylation. You're turning the oxygen into phosphate so that you can create ATP, which is the battery that runs the body. So between complex 3 and complex 4, and complex 4 is the kitchen where oxygen becomes water, but you've got to move the electrons from complex 1 to 3 to 4. That's basically how they work. But there's something called the signalosome between complex 3 and 4. And it's basically a rectangle. And it's got 4 parts to it. But the most important part is a molecule of retinol. And literally the electrons move from complex 3, ride the tail of the retinol to get to complex 4. And this is the work of Dr. Hammerling out of Germany in 2016. Absolutely mind-blowing research that he did. But what it does is it syncs up research that was done back in the 20s, 1925 and 26 by Montrose T. Burroughs, who was at the time, he was a famous physician working at the Rockefeller Institute. So our sphincters can tighten up on that one. But he wrote an article in 1925 and 4 articles in 1926, highlighting the fact that retinol deficiency was the cause of cancer. In 1927, the Nobel recipient, Johannes Fibinger, he got the Nobel because he said that cancer was a parasite. He rescinded that after he got the Nobel, wrote an article in 1927 and said, actually, no, it's a retinol deficiency. And then 4 months after he wrote that article, he's dead. I'm not sure why, but he wasn't working at the Rockefeller Institute. He was over in Europe. But there were other authors in that era talking about retinol deficiency causing cancer. And so what is cancer?
It's an oxygen issue.
It's an oxygen issue. I think it is pre-copper metabolism on planet Earth. Before you had the copper proteins, the copper enzymes, and the capacity of copper to help deal with this oxygen thing, you had some pretty rugged metabolism taking place. And it's now increasingly documented that iron accumulates in cancerous tissue. And I'm sure it has to do with light. It has to do with the inability to move these electrons, right? And what happens to the cancerous tissue is it gets ravenous. What we're supposed to believe it's ravenous for sugar. No, it's ravenous for iron. It's iron that's driving this whole metabolism. And what are the two cutting edge therapies for cancer today? Iron chelation therapy and retinol therapy.
So
And
then would that make cancer a disease of fear?
I think that's brilliant, Kelley. Absolutely. Yeah. I think that makes so much sense. At a cellular level, there's fear.
Yeah.
And so the body is retrenching. And in fact, when we're in a state of fear, our DNA shrinks.
Yeah.
We tighten, we get tight. When we're in a state of happiness, we're more relaxed, right? And so the histone metabolism, where the DNA, histones are really important proteins inside the DNA. Why are they so important? Because they can take 1.7 meters of information and condense it to 9 micrometers. It's like, wait a minute, I don't think I understand that. But the important thing is, I just found the articles just this week. They're now, and these are 2024 articles, they're now acknowledging that histone metabolism is all copper driven. The unfurling of the DNA so we can have transcription is all driven by copper driven proteins. It's like, oh my gosh, I mean, they lied to us about genetics too. And so no surprise there. But I think the key is back to Lauren's original desire to get into the iron overload. The body is really designed to recycle. Every facet of our existence needs to be recycled at a cellular level. That's why autophagy exists. But even within that, when you get into the mitochondria, the iron's got to get recycled.
Yeah.
One of the great scientific unknowns is, how does oxygen actually get into the mitochondria? They don't know. Wittenberg, 2007 is the closest they've come. And that husband and wife team said, we don't know. We don't understand. To me, it's the most basic piece of knowledge that we need to know is, how does that oxygen thing get inside the mitochondria so it can become water? And the most provocative theory is by a Mexican MD, PhD, Solis Herrera, Sun Man, right?
Yeah.
Arturo Solis Herrera, and he talks about human photosynthesis, and that makes so much sense. So you've got, melanin on the outside, you've got the mitochondria on the inside, and what's melanin doing? It's splitting water. So that's an elegant model that is being, of course, rejected by traditional science, but it makes so much more sense. But the important point is, the iron needs to be recycled. Somewhere iron is involved in this mechanism of delivering the payload of oxygen. And that iron needs to be turned back into iron sulfur clusters or back into heme. And both of those mechanisms are copper dependent. So that when the individual starts to get really stressed out at a macro level, there's two hormones that get released: adrenaline and cortisol. And a wonderful article that talks about this whole dynamic is by Zamin Pira, Zaminpira, 2019, talking about the hypoxia that's produced in fear that creates cancer in the human. And it builds on your point, Kelley, perfectly. But what they don't talk about in the article is, what does adrenaline do to iron and what does cortisol do to copper? Well, adrenaline is it's a supercharger for driving oxygen into the tissue. We're going to make sure we've got oxygen. And by gosh, we're going to make sure you get a lot of oxygen. So you've had that burst of energy so you can outrun the bear, or you can lift the car off your baby, or whatever the crisis is. But it's meant for short bursts of energy. Cortisol, completely different. Cortisol, we're told that, oh, it's helping us produce sugar, or we're enhancing our glucose metabolism. It's a little more complicated than that. So what cortisol does is it triggers a protein called metallothionein, very important protein for storing metals. Well, it stores copper 1,000 times stronger than it stores zinc. So, but what does cortisol do? It increases metallothionein production 4 to 5-fold in the face of stress. And so what's happening is, if someone is under chronic stress, well, let me back up. If someone's under acute stress, you just had an argument with your spouse, or you had a bad meal, or you've got this deadline, you're going to dump a lot of magnesium. That's acute stress. We call it the magnesium burn rate. But if you get caught in a cycle of fear that you're alluding to, you're going to be producing not just adrenaline, you're going to be producing a lot of cortisol. It's a constant drip of cortisol, constant rise of metallothionein, constant binding of copper, and you're going to lose the ability to convert oxygen into water. And then what's going to happen? The hormones are going to go crazy, because oxidative stress is out of control. And who controls oxidative stress? Oh yeah, it's those copper enzymes, superoxide dismutase, catalase, glutathione peroxidase, ferroxidase. I mean, there's a whole network of enzymes that no one knows about. And why are they important? Because they're 1,000 times more powerful than the vitamin C and other antioxidant nutrients that people think, oh, well, I'll just take some extra ascorbic acid, wink, wink. And so the cortisol takes copper offline. And Mother Nature's not being mean. Basically, Mother Nature is saying, you can't seem to handle your stress. I'm going to take you offline. And then there's a fear response. If someone starts to get more fatigued, or they can't respond to their environment. So then you get this vicious cycle of fatigue and fear and fatigue, and it's overwhelming. And what's at the basis of it is the inability to convert oxygen into water to release energy to respond to the crisis, whether it's a short term or a long term. And that's really what the whole intent of the root cause protocol is, to try to overcome that. But one of the great limitations is that Lauren is alluding to, is the amount of iron we have inside our body. We look, switched on and intelligent. I look a little older than you guys do, and I've got a few more miles on you. But the way you can measure your aging is to take your age and multiply it times 365. And that way you see how many thousands of milligrams of iron you have in your body. Because we add 1 milligram of iron every day we're on planet Earth. Well, I've got like 28,000 milligrams of iron. My body's designed for 5,000. Your bodies are designed for 4,000. And what's really cool is there's only two reasons why women outlive men. Only two reasons. First reason, women are smarter. That's a biological fact. And the second reason is you got 40 years of blood loss that I never got. So you've been dumping iron for 40 years. You're designed to dump iron. And the guy who figured that out, his name was Jerry Sullivan, MD, PhD at the University of Florida in Gainesville, pathologist. And he figured out why women had such low heart disease when they were menstruating. And then as soon as they went into menopause, they started to develop heart disease. And he was able to prove it through the whole iron cycle that gets dysregulated as the woman comes out of menstruation, goes into menopause. And what is she missing? Well, she's missing copper. She's missing retinol. She's got a hyper production of a hormone called hepcidin. And what does hepcidin do is it keeps the iron stuck in the tissue, back to the iron overload that Lauren is interested in talking about. And that iron, if iron is not recycling, if iron is not moving, it's reactive. And it starts to react with oxygen. And it starts to ding DNA, it starts to ding proteins, and it starts to ding fats. And that's where all the oxidative stress is. It's the increased methylation because of the iron. Iron drives increased methylation. Well, then we're into Horvath's clock to find out how old you are biologically. Forget the chronological thing. How old are you biologically? And we've got this whole dynamic around needing to find out that the person is not responding to their stress because he can't make energy.
Yeah.
And that just festers. The iron starts to build inside the tissue. And everyone knows about, not everyone, but most people know about ferritin, right? They've heard of the iron storage protein. Well, there's actually 5 types of ferritin. So there's ferritin heavy chain, which is like an ATM machine. I can put it in, I can take it out. I can put it in, I can take it out. Well, that ATM function requires copper. So the heavy chain requires copper. Well, there's a light chain. So the reason why it's called heavy versus light, heavy is referring to heavy metal. And we all know that copper is a heavy metal and it's bad, booga booga bad, and we got to get rid of it, right? So anytime you see heavy chain in the literature, whether it's referring to ferritin or anything else, it means it's involving copper. They want you to think it's bad. And so heavy chain is why we're here. Light chain, and it's really important in the heart, heavy heart, but the light chain is more prevalent in the liver, light, liver. And so what's the light chain doing? It's storing iron and you can't get it out. And so it's a one-way trip. So then we've got a third form. It's called serum iron, or excuse me, serum ferritin. And that's what people know about. Oh, my ferritin is low or my ferritin is high. Well, the 2 most obnoxious words on planet Earth as it relates to medicine and nutrition are high and low. No, is it bioavailable? That's the issue. But the thing is, ferritin is designed to be inside the cell. It's not supposed to be in the blood, which is outside the cell. When it shows up in the blood, it's extracellular. It's not where it's supposed to be. Not my idea. That's when I had the conversation with Douglas Kell probably 5 or 6 years ago. It was mind blowing. I asked him point blank. I said, Dr. Kell, what's the ideal ferritin for a human being? He said 0. And I was in shock. He said, Morley, I want to make sure you understand this. He said, rising ferritin in the blood is not a sign of iron vitality. It's a sign of organ pathophysiology. And so that's our third ferritin. Then we have a fourth ferritin called denatured ferritin. It's also called hemosiderin. So what is hemosiderin? It's where iron goes to die. So the ferritin molecule can hold up to 4,500 atoms of iron. Now, what's important for people to understand is that the reason why iron is so dangerous is it has 4 unpaired electrons. Well, Mother Nature abhors anything unpaired. And so 4 times 4,500 is a big number. A lot of unpaired electrons. What is hemosiderin? Hemosiderin holds 10 times more iron than ferritin, but it can't get out. And it's found in liver tissue, spleen tissue. Nobody talks about the spleen. And if you've ever heard of age spots, liver spots, that's ferritin. That's hemosiderin.
Lipofuscin.
Lipofuscin is an expression of that, absolutely. But wait, there's more. What I learned earlier in the year, this is really unsettling. Is there something called magnetoferritin,
Yes.
right?
Yes.
And so that's the iron is becoming so compressed and it's taking up less space, but it's 200 times more magnetic than the iron in ferritin or hemosiderin.
Mhm.
And there's a whole school of thought that's emerging now that what's behind all of the chronic disease, it's the magnetic field that this magnetoferritin is throwing out to cause heart disease, neurodegeneration, cancer, kidney disease, you name the affliction. And there's this concentration of iron that is so great. And again, we're thinking, what? No, but I've been trained that I'm anemic and I need more iron. Well, if I was Satan, that's exactly what I'd want you to believe, is you need more iron and get rid of that copper thing. And what's happened, I think, over the last century is humans have become so magnetized, and it's thrown off our light, it's thrown off our cycles, it's thrown off our clocks, it's thrown off all of our enzyme activity. And no one's the wiser because everyone thinks they're anemic. And I need more iron. And we have self-medicated. We didn't know that the food we were eating was just toxic to the core. But then we've added all these sources of iron through our supplements and what have you. And all the while not knowing that, in fact, copper is the general and iron is the grunt, the foot soldier. Not knowing that every facet of iron metabolism is copper dependent. That the whole process of making blood, it's just so mind blowing. It's a very elaborate mechanism. It takes, several days to make new blood, but every second of every day, we're turning over 2.5 million red blood cells. So we've been talking, I don't know how long we've been talking now. Well, almost an hour. And so that's a lot of seconds. And we're turning over a lot of iron in that process. And no one's talking about that. No one's aware of how important this iron recycling process is. Hi there.
Hi.
How are you? Hey, hi up. Lauren and Kelley.
Hi, Lauren.
And this lean down so they can see you. This is Dr. Liz who got me started.
Hi.
Little simple comment about the innate healer. Innate healer, what is that? So that's what got me started researching 15 years ago. So the thing is, people don't know about, sweetie, keep the light running in there. Liz,
Huh?
keep that down. Keep it down, sweetie. No, keep it down. Okay.
It's a complicated system,
Yeah.
sorry.
Sorry about that. So now we're seeing entropy in play, but the problem is that what happens is we're accumulating iron. We never knew what was happening during the course of our life. I think about the diet I had when I was growing up in Baltimore, the Pop-Tarts, the sugar frosted flakes, the OJ I had in the morning, and the Snickers bars in the afternoon. And nobody thought about that, all that sugar and how that affected iron. So it's amazing to get into it.
So now, one of my favorite sayings of yours is sugar is white iron because it blows my mind. And I want to go back to the iron recycling system, and I want to go back to that design that we are. And you talking about how iron gets stuck and it doesn't have its way out, but I want to talk about carbohydrates, sugar, and water flowing into the cell. And then when you are utilizing fat as your fuel, you're pulling water out of the cell. And if just so the audience knows, I met Morley when I was bleeding every day and was under the 8 ball and had iron problems. And he was the one who kept me from not taking iron supplements, even on the sharpest razor's edge. So I I started to need to pair the root cause protocol with some therapeutic ketosis to regain my energy. So I couldn't I didn't have to take iron supplements, right? In terms of like, having like bottomed out bleeding way
Right.
past how the root cause protocol would recommend blood donations. And the recycling system. So now what you just said about Frosted Flakes and about all the sugar, and if sugar is white iron, and we recycle, when we metabolically are going into flexibility and we're able to move from fuel systems, sugar and fat, that has to tie in with the way we metabolize energy and metabolize oxygen, right?
Well, the mechanism, and we're going to get the initials wrong, but I think it's SOCS3, or it's um, Svetlana Lutsenko at Hopkins makes
Yeah.
mind on copper. She wrote an article, I think it was like 2019, about this very protein that's in the mitochondria that is the switch between, are we going to burn carbs, or are we going to burn fat? And it's a copper dependent switch. It's like, oh my God. I mean, there's so many of these mechanisms in the body that nobody knows about that are driven by this primal mineral that has been basically expunged in large part because of changes in farming, changes in food processing, changes in pharmaceuticals. You know, that's a whole nother, probably a whole nother podcast. But the important point is that I think I think the mitochondria were originally designed to burn fat.
Yes.
And I think they've been turned into sugar factories. And
Yes.
there's a price to pay for that. And the go back to, again, let's go back to the great oxygen event. Before oxygen came here, how do we make energy? We fermented sugar to make energy. It was a low energy production, but it was fermenting sugar. And what was the dominant metal at that time? It was iron. It's always been iron. And so there is this axis between iron and sugar. The other axis is between copper and fat.
Yep.
You can't absorb copper unless you have fat in your diet. You cannot metabolize fat unless you have copper in your body. That's the work of Chris Chang at Berkeley. It's done some very important work around the whole mechanism of copper enabling optimal fat metabolism and lipolysis. And it's like, that's not being taught anywhere. And so it's just, we have this complete inversion of thinking that the food pyramid that I grew up with, I don't know about you guys, but I grew up with the food pyramid. It was as demonic as the day is long.
Yep.
It was all carb driven,
Yep.
which is going to crank the iron engine. Iron's going to get stuck. It's going to fester. As soon as iron is stuck in a mitochondria or stuck in the tissue, it's going to fester. It's going to create dysfunction. And then we're trained to believe that that's disease. No, it's not disease. It's metabolic dysfunction because we can't turn the oxygen into water because the chef is MIA. There's no chef inside the kitchen to keep track of the pots and pans and the oxygen that's flowing through it. That's, to me, it's so painfully simple how the body works, but we get caught up in all this jargon and people love to use the phrase metabolic dysfunction, but they don't get down into the enzymes. They don't get down into the complexes. They don't get down into the minerals where if you don't have magnesium and copper, you're not going to make energy. And that's why we're here. We're here to make energy so we can learn our lessons, so we can get off this godforsaken planet and go someplace else.
Yes.
That's my theory of life.
Yes. So inflammation is going to play into that, both on like the physiological level and also the emotional level, inflamed emotions, inflamed stress, inflamed.
So actually, when you get inside the mitochondria and get inside the engine of the mitochondria, it's a two-stroke engine. First stroke turns oxygen into H2O2, into hydrogen peroxide. The second stroke turns it into 2 molecules of water, 2 H2O. That's really important to know that. So if a biochemist were here and we put them on the spot and we said, how do you spell inflammation? He'd say, oh, it's H2O2. So it's what's happening is people are stuck in making hydrogen peroxide because they can't flip it to make the energy. They can't make the water, so they can't release the energy. So the tissue gets hot and inflamed. And guess what's building inside the tissue? Iron. Because it takes energy to have all the recycling systems work. If you don't have energy, you can't recycle the amino acids. You can't recycle the iron. You can't keep calcium in check. I mean, it's just every facet of recycling is energy dependent. And that's why one of my other heroes is Douglas Wallace at Children's Hospital of Pennsylvania, 2005. The greatest defect in medicine is their inability to understand cellular energy deficiency.
It also highlights the connection with the cell danger response, Dr. Robert Navio's work.
Absolutely.
And
Yeah.
then you can take that and you can connect it to the whole polyvagal theory and the different fight, flight, freeze response and the type of metabolism or where the person gets stuck in metabolism can explain the stage of the nervous system that they're also stuck in, which explains their emotional state. When we're talking about fight, it's anger. When we're talking about flight, it's fear. When we're talking about freeze, it's shame. And so everybody has all of these things compartmentalized or their own fields of research, in my opinion, to help keep people really confused and not, the left hand doesn't know what the right hand is doing. But
Exactly.
really, what all of these fields are kind of explaining is the same thing. The way you're explaining it is in much greater detail, and you have all of the enzymes and, the systems in place. Whereas when you look at the polyvagal theory, it's not that detailed.
Let's stay with that for just a minute. Vagus nerve is real important, right? The wanderer, right? I mean, Dr. Liz taught me a lot about the vagus nerve. I was fascinated by the vagus nerve. But I always wondered, what is the vagus nerve? Well, it's Houston, we have a problem.
Yeah.
It's wandering all over the body looking for signaling that's not right, right? And what's really important is to know, where does the vagus nerve end its journey in our brainstem? And there's a part on either side of our brainstem are nuclei that are the color of the stocking behind you, Kelley. Sky blue again. And it's called the locus ceruleus. And that's Latin for blue dot. And they're the size of your thumbnail. And it's the highest concentration of copper in the brain. And what is the precursor to all neurodegeneration? The elimination of copper in the locus ceruleus. Well, why does it leave? Well, because of the environment that we live in. But the important thing is, the vagus nerve is sending the signal to the locus ceruleus. Houston, we have a problem. What the locus ceruleus does is it produces 70% of the noradrenaline that the brain uses to respond to inflammation. And when you mix noradrenaline with another chemical called somatostatin, right?
Mm-hmm.
That stops inflammation in its tracks. But there's a catch. How do you make noradrenaline? Well, you got to have copper.
Mm-hmm.
Take dopamine, mix it with DBH, dopamine beta hydroxylase, and you're going to turn into noradrenaline. No one talks about noradrenaline. Everyone loves to talk about adrenaline and cortisol, but no one talks about noradrenaline. It's the antidote to all our problems. And somatostatin, and this is going to get us into maybe another podcast, but there's a very important enzyme that activates neuropeptides. So our cell phones don't work unless they're turned on, right? Can't make a call if it's not turned on. Well, it turns out that the body makes inactive neuropeptides, inactive hormones. All the hormones, they're actually 4,699 signaling peptides in the human body. And they're all activated by one enzyme. It's called the PAM enzyme. Where is it richly expressed? Oh, what a coincidence. It's richly expressed the locus ceruleus in the hypothalamus, these very sensitive brain regions. And what it does is it takes these pre-hormones and makes them active so that the body can actually use them. And where we find ourselves on the planet now is because of glyphosate, the PAM enzyme has been silenced.
Mhm.
And most practitioners, I would venture to say 99.999% of practitioners have never heard of the PAM enzyme. I've talked to world-renowned neurologists who had never heard of it. And it stands for peptidoglycine alpha amidating monooxygenase. 35 letters long. And there's a husband and wife team that studied that enzyme for 45 years, 20 years at Hopkins and 25 years at UConn Medical Center. Now, that's a big deal to study one enzyme for 45 years, to have funding, steady stream of funding. And where I think it's so important for people to be aware of this is that if the PAM enzyme is being silenced because of glyphosate, ding, 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 because glyphosate has a preference for copper to chelate it. If that enzyme is being silenced, then people need what's called hormone replacement therapy, wink, wink. The reason why they need the therapy is because their natural innate intelligence has been silenced.
Yeah.
And that's where we find ourselves on the planet now, is all of this chest beating and histrionics about we're going to change big pharma, but no one's going to talk about copper. No one's going to talk about oxygen. No one's going to talk about iron. And no one's going to talk about the fear that's playing in the background of our physiology. It isn't an emotional issue, it's a physiological issue.
Yes.
You both have picked up on the importance of that, which is so important because I truly believe it goes back to the beginning of time. This fear response to oxygen. What am I going to do with that? I don't have the mechanism. And then copper comes along and says, relax, I got you covered. And there are so many examples of where copper allows relaxation and recovery in the body, but that's not taught in doctor school. Everything's disease-based, not energy-based. And that's where I think the breakdown is in medical education. Because in my world, there is no disease. It doesn't exist.
Yeah.
It's a labeling technique to create fear in the individual so they become compliant with some drug that's been produced,
Yes.
if that makes sense.
Yes. And in a way, it's a better focus would be to illuminate where there is a lack of reciprocity and balance.
Exactly. And so I think the key for people is that, again, to amplify the point, if the iron in your body is not being recycled and being circulated, again, the focus of modern medicine now is to use ferritin. How much iron do you have stored? That is an absolutely atrocious metric to use. How much stored iron do you have? No, you don't want to know that. You want to know how quickly are you turning it over. And as long as iron's moving, everything's fine. As soon as it gets stored, it becomes a problem. And so the whole mindset of medicine is to think about stored iron, not moving iron. And you can't move iron without copper. And if iron's moving, you're not going to have oxidative stress the way you do if you have stationary iron. And people need to understand that mechanism is the focal point for all. There's 32,000 conditions in the Merck manual. Every one of them starts with Douglas Wallace's cellular energy deficiency. Because what that phrase really means is we're making oxidative stress. We're not making ATP. And so we're going to create this nuclear reactor of oxidative stress that's going to start pinging organelles and all of the substrates inside the tissue.
And you mentioned the brainstem and where the vagus nerve begins, so to speak. And that is also the same place that the mitochondria communicate to when they are stuck in the cell danger response or the cell danger response has been activated. And so this concept of like nervous system regulation through various mechanisms without the understanding of what's happening at the cellular level, you can be kind of fighting a never-ending battle of stimulating your vagus nerve and doing all this stuff if you're not addressing what's happening inside the cell with oxygen and iron and copper, correct?
Absolutely true.
Yeah.
Absolutely. And I think what's important is that people need to realize that before there was nerves, life forms did not always have nerves.
Mm.
What did life forms use to communicate with each other before there were nerves? They used copper. Copper was the original communicator.
Telepathy. Sorry.
Yeah, okay. But
Oh,
what's
that's copper. You just said they used copper. That's literally telepathy.
I know that makes so
Sorry,
much sense.
that's what it is. Oh my God. That's like instant love.
So before, when the telegraph came out back in the 1860s or 50s, whenever it was, they used iron wire. That was the original wire that was used for the telegraph machines until they discovered that copper was 3 times faster for moving electrons. And then everything flipped, literally overnight.
About making energy. It's 3 times as much energy in your balance sheet, your ATP balance sheet. That's the same equation.
Right. And so I think what there's a recognized, I'm not going to mention by name, but there's a recognized biohacker. And he was talking to a mutual friend of ours. And he said, what are we going to do about the Morley problem? Because I've reduced all of these mechanisms down to 3 players, the 3-ring circus. And it's and does the root cause protocol solve all problems? No, but it's an incredible foundation to start with because it frees up the light, it frees up the water, it frees up the iron, and there's so many secondary and tertiary effects, and it allows the body to regain its intelligence. I firmly believe that there is, that Dr. Liz introduced me to the innate intelligence. Well, what is it? It's copper metabolism. That's the innate intelligence. That's my take of the world. But what's hard to get people to accept is that it's that simple.
Which is the metabolism of love, which is reciprocity, because here is a lack of balance, and it's a lack of back and forth. It's a lack of bidirectionality, and reciprocity is actually the opposite of fear, which is love.
Well, it's yin yang at its essence, right?
Mhm.
And so within the world of traditional Chinese medicine, they have heat and they have qi. Well, what is heat? It's a buildup of iron. What is qi? That's copper at its essence. It's allowing the flow of energy. And one of our colleagues, gone through the program like Lauren did, she does reflexology, and she studies Chinese medicine very carefully. And there's a German acupuncturist, and he's proven that the meridians are copper dependent. It's like, that makes so much sense. But what do we do here in the States? We use steel needles, which are made of what? Iron. And it's like, why don't we use copper needles? Of course. And guess where they use copper needles? In China.
Yeah.
So fascinating. Well, what a great conversation and what a great way to tie all of this together. I'm sure we could sit and chat for hours. At least I know I could.
Yeah. Well, I appreciate the chance to have this type of conversation because it's there are not many people that really resonate with this message or
No,
are willing to accept the simplicity of it. I mean, it's enormous. And one of our colleagues, Christian Foster, Christine Kershaw, she's the one who came up with the phrase, the simplicity and enormity of copper. And that's really what it is. It's this very simple mechanism, but it has this enormous footprint in our environment.
Yeah.
I think that this has really, it's so beneficial to have, you gave us so much value to understand from an angle of, like a wellness is a total picture, right? And everything is that universal language, that one universal language is wellness, but there's ways to say the same, you know, we speak in Spanish, we speak in Chinese, we speak in Russian, and we're speaking about that universal oneness. And we live multidimensionally, right? We're multidimensional beings.
Right.
So we do have to tend to our minerals, just like we do have to tend to our light environment, just like we do have to tend to our emotional landscape. I always like to say it's yes and. So you have given us so much foundation of that language of the minerals that you can't leave out of the equation. You just can't.
No.
They have to be included. Excuse me.
And just to reinforce the message for the listeners, iron is the mineral, iron accumulation is the mechanism for aging.
Yeah.
And copper is the mechanism for longevity.
Yep.
When you get into the biology of it, plants especially, but even in animals, the concentration of copper is so important for the development of the tissue. And again, all of this awareness and wisdom is lost in the world of modern medicine.
Yeah.
So appreciate the chance to have this chat. So thank
Yeah,
you.
thank you for chatting with us today and sharing your wisdom. I mean, I know I've learned a lot. I'm sure the listeners will gain quite a bit. And you put it in such an elegant manner that, I think the average layperson can really begin to grasp some of these subjects that can feel really complex when you're going out into the world and trying to navigate your way back to wellness. So thank you again. We really appreciate it.